Okay, so in this lecture we will be using truth tables to test the validity or invalidity of an argument. Fine. So we know what is an argument. An argument will contain premises and conclusion, and we need to establish that the conclusion follows out of the premises. Now suppose if we take a simple argument, like there is an argument where the first premise says P implies Q. Okay, so this is the first premise. The second premise says P. Okay, this is the second one, and therefore Q. So this is the conclusion. Now how to test the validity of this argument? With the help of truth table. We can also, and later on we will also be using a lot of methods to test validity or invalidity and so on. But right now, if suppose somebody asks us that what is how you will test the validity or invalidity, or this is basically, as I told you, that truth tables are called as decision procedures. So how will you decide that this argument is a valid argument or is an invalid argument? Suppose we take it vis-a-vis, there is another one, it's having the same kind of premises, P implies Q, Q, therefore P. So we will use both these arguments, because you can see that this is one statement, this is another statement, this is the third statement, and it is like the premises. This is the premise 1 of this question, this is premise 2 of this question, and this is the conclusion of this question. So we need to find the value of it. Similarly, this one is the premise 1, this one is the premise 2, and this is the conclusion. So how we are finding the validity or invalidity of these arguments? Because we can use truth table both for testing, say, whether a statement is contingent, or whether a statement is a contradiction, or whether a statement is a tautology. Similarly, we can also test with the help of truth tables that whether an argument is a valid argument or is an invalid argument. So let us start with this. Let us start with the first example. Okay, how to draw the truth table, and then how to find out whether this argument is valid or invalid. As you know that there are only two things, so there will be 4 rows. One is P, Q, P implies Q, because there is nothing more which we have to find it out, right? So we will put true, true, false, false, true, false, true, false, and we will calculate true, false, true, true. Excuse me. So now you can see that it is just the truth table of a P implies Q. Now, but drawing this truth table, or if you write just these things, it will not suffice our requirement sorry, of showing whether this argument is a valid argument or is an invalid argument. So how to find out whether this argument is a valid argument or an invalid argument? What were our premises? Our premises were P implies Q and P, and our conclusion was Q. This is something which you need to remember. Now you need to find out that, okay, this is my premise 1, this is my premise 2, and this is my conclusion. Okay? Now, what is the definition of validity, if you remember? The definition of validity says that an argument is valid if there is no substitution instance which can make the premises true and conclusion false. Now this is going to give you a very keen understanding, or very clear understanding of that how this argument is going to be valid or invalid. Our premises are this, and this is our conclusion. We need to check whenever both the premises are true, whether the conclusion is also true. Now if you see the first line, this and this, okay, you will see that this premise is true and this premise is true, and the conclusion is also true. So fine. Now if you check with the second line, you will find that this premise is false, so there is no need to check. Here there is true, but then again it is false, no need to check. Here it is true, but again it is false, so no need to check. So you will see that there is only one line and one good line. You can see one good line which shows that whenever the premises are true, the conclusion is false. And there is no substitution instance which can make the premises true and the conclusion false. Therefore, this argument, okay, this argument is a valid argument. Why? Because whenever the premises are true, the conclusion is also true. There is no other case in which the premises are true and the conclusion false. Like suppose you see that this is the false line, but then you will see that this is also false. Here also you see that this is false line, but then you see that here also it is false. So it is not sufficing, or it is not satisfying our conditions of validity, or say it is not violating our conditions of validity. Our condition of validity is only checked with this line, and it says that this argument is a valid argument. Now, contrary to this, let us take one. We have already said that we will also check another argument. I will remove this, I will draw it again, it will not take much of time. We will draw the same thing. Okay, now our argument is different. Our argument is P implies Q, Q therefore P. Now this is our argument which needs to be checked. Again, the truth table will remain the same, right? We will draw this as true, true, false, false, then true, false, true, false. And here we know true, false, true, true. Fine. But now you know what are the premise. The premise is, this is premise 1. Okay, I have to do this as well. This premise 1 will remain here. These two will change. This is premise 2. And this is conclusion. Fine. Okay. Now, to check, we have to check the validity or the invalidity of this argument. We have to check this line and this line. That means premise 1 and premise 2. Where there are two, this line is true. So this is fine. It is a good line. We call it a good line because it is not violating the principles of validity. Now you see this is also, both of them are true, but here it's false. This is a bad line. Okay. Now, in the rest of the cases, it's not coming like both the premises are true. Now, the bad thing is that we have a good line and we have a bad line. So, what this argument will be? Somebody can say that this argument is both valid or invalid. No. An argument will be either valid or invalid. It cannot be both. So how to decide whether it is valid or invalid? It is an invalid argument. Why? Because one bad line is enough to prove that this argument will not follow the rules of validity, because there is a substitution instance. There is a substitution instance which can make the premises true, but the conclusion false. So even if you see that we have just changed the premise and conclusion, the argument looks superficially the same with the first argument, but this argument is an invalid argument. Fine. So you need to understand that even if there is one good line, but if there is one bad line, suppose if you are solving a question where there are 5 good lines and 1 bad line, still that argument will be invalid. If there is just one single bad line, there can be an argument where there are 5 bad lines and 1 good line. That is also invalid. But there you do not feel like that, okay, this argument is valid or invalid. You feel like that, yes, it is violating the rule so many times. Here it is violating the rule only once. but does not matter. If it violates the rule even once, then also this argument is going to be an invalid argument. So we know this argument, P implies Q, Q therefore P, is an invalid argument. Okay, now let us take these 4 examples. I am not going to solve it for you, but I am going to tell you a few things which you need to remember for using truth tables, or for, in fact, in the later part of the course also. You need to be very clear about this understanding that you need to grasp the structure of an argument, right? This is something which we have been discussing for last few lectures. Now, we have already seen these 2 examples. P implies Q, P therefore Q, and P implies Q, Q therefore P. We have already discussed. We know that this is a valid argument and this is an invalid argument. Similarly, this and this also looks quite the same. Here there is negation P and here there is negation Q. Now you will draw and see which of them is valid or invalid. You can pause this video and check for yourself whether this is a valid argument or this is a valid argument, or this is an invalid argument or this is an invalid argument. I leave this exercise for you because you can now solve it with the help of your truth table technique. That is what we have learned in last few lectures. You can pause the video as I told you and check. Now, once you have paused the video and you have checked, let us see what the analysis tells us. The analysis tells us that this is a valid argument and this is an invalid argument. Okay, here you will find a bad line, here you will not find any bad line. Like here you will find a bad line and here you have not found a bad line. So this was a valid argument, the same goes for this argument. And this is an invalid argument and this is also an invalid argument. Now, there are very specific names for these arguments. Like this argument, which is a valid argument, it is a very standard valid argument. Its name is modus ponens. In short form, it is called as MP. Once we will be solving the rules of inference, or once we will be discussing the rules of inference, we will be talking about this in detail. Similarly, this argument, it is also a valid argument. It's having a very specific name. It is called as modus tollens. Short form is MP. Now these two are also having very specific names. Okay. It is called as fallacy of affirming the consequent. And this is called as fallacy of denying the antecedent. Fine. So fallacy of affirming the consequent and fallacy of denying the antecedent. So this is called as fallacy of denying the antecedent. This is called the fallacy of affirming the consequent. Now if you see this fallacy of affirming the consequent, fallacy, if you check this word fallacy, what does fallacy mean? Fallacy is nothing but, if I write it, it's defective reasoning. There is a defect in reasoning, therefore we call it fallacy. When we say something is fallacious or something is falsified, these kind of expressions come in different kind of languages or different kind of sciences. Similarly, when we say something is a fallacy, it logically means that there is a defective reasoning which is associated. That means there is a defect in reasoning and people have not understood it properly, and therefore we are committing this fallacy. Now this fallacy of affirming the consequent, looks very similar like this one, modus ponens, right? So we say that it bears superficial resemblance with modus ponens. Similarly, this fallacy of denying the antecedent, is having a very similar structure like that of tollens, right? So we call it like this fallacy is having a superficial resemblance with modus tollens. So if suppose somebody asks you that which fallacy bears superficial resemblance with modus tollens, so the answer is fallacy of denying the antecedent. Somebody asks you which rule of inference bears superficial resemblance with fallacy of affirming the consequent, so it will be modus ponens. No, you can change. You can say that what is the corresponding valid argument, that is these will be this valid argument, and this valid argument is also called as rule of inference. They come under the rules of inference. So once we will go to the next part of the syllabus, so you will be having rules of inference to prove something, right? So rules of inference are basically valid argument forms. This is an argument form. You can see that it's an argument form. This P and Q can take any kind of values. Irrespective of what kind of values it will take, the argument, whether it is valid or it is invalid, is something which we need to check. So this is having superficial resemblances, and these are having superficial resemblances. So this is something which should be known to us, and these are basically fallacies, and these two are basically valid arguments. Let us take the next example, that is R wedge S implies R dot S, R dot S therefore R wedge S. Now we have to check whether it is a valid argument or an invalid argument. Now if you see this argument, you see that this argument is more or less quite similar to this argument, right? That is P implies Q, Q therefore P. So if this is P and this is Q, so this is also Q and this is P, right? So P implies Q, Q therefore P. It looks like this: P implies Q because there is an implication sign, then Q and therefore P. So it is superficially looking exactly like this, or you can say that we have replaced R wedge S with P and R dot S with Q. So given that understanding, this argument and this argument exactly have the same structure. Now we know that this argument is an invalid argument, right? We have checked it a few moments back that this argument is an invalid argument. If you remember the name of this argument, it is called as fallacy of affirming the consequent, right? So fallacy of affirming the consequent, this argument, right? So this argument and this argument are exactly on the same platform. So if this is an invalid argument, so this argument should also be an invalid argument. This is the basic understanding. So let us check with the help of truth table that whether this argument is also an invalid argument like this argument. So how to draw the truth table of this? So I will remove this, and okay, we will take this from here, and we have R S, R wedge S, R dot S. Fine. So we know that we will also require this. So we can draw the truth table in this fashion, but maybe it will be a little bit difficult for you to pick it up initially. So we know that the arguments premises are R wedge S implies R dot S, R dot S therefore R wedge S. This is the argument, right? So we can draw it just here and then interpret, but that interpretation may get a little bit difficult. Initially we are not able to see things very easily. Then we have a proper vision at how to look for or how to find the conclusion. So once we understand that, we will be very comfortable in solving these kind of questions. So what I will do for you is that I will also make, I can make it like this. What I can do, I can make it like this, that I keep R over here, S over here, R dot S here, and R wedge S here. Okay, or maybe I can remove this from here. And what are the premises which we have? We have premise like this. We have a premise like this. We have another premise like this, and our conclusion says R wedge S, right? So maybe we will draw it like this. Does not matter if it is repeated, we will interpret it, right? So okay, since there are only two values, so it is an easier task. We draw a truth table like TTFF, then TFTF, and we know that this will be T, this will be F, this will be F, this will be F. And if we draw our wedge S, so it is true, 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 false, and this whole value can come here, so it will be T, F, F, F. And if we take the value of these two, so it is true, this is false, this is also false, and this is true, right? So this is the value, and we know R wedge S, but again I will repeat it over here for your convenience. So it will be T, 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 and F. Okay, so now this is how the truth table will look, right? Now once this truth table looks like this, what and how to check whether this argument is valid or invalid? Now we know that one of the premise is this one, yeah? So we will say that this is premise 1, and this is the second premise, so it is premise 2, and this is the conclusion, so I write it over here, that is the conclusion. Now we have to find that whether this argument is valid or invalid. Let me remind you, this structure of argument exactly looks like the structure of an invalid argument, the fallacy of affirming the consequent. Now we replace the P and Q with R wedge S and R dot S, as you have seen. So now what is going to be the conclusion, and how we will check that whether this argument is valid or invalid? And we know this is premise 1, this is premise 2. So we are concerned with this value, fine, and this value, fine. Okay, so and this value, this is the conclusion, so this is the third one. Okay, now we have to check where the two premises are. This and this line is fine, and this is the conclusion. So if you check with this line, where both the premises are true and the conclusion is true as well, so this is a good line. Now if you see here, there is no other line. So in fact there is no other line to check. So you know by the analysis now that if the premises are true, the conclusion has to be true. Therefore this argument is a valid argument form, irrespective of the fact that its pattern, if you see the structure of an invalid argument was taken, some data or some values were shifted into that, and we checked it with the help of truth table, and we find that, look, this is a valid argument. There is absolutely no problem about it. This is a valid argument. Why? Because whenever the premises are true, the conclusion is true. There is no bad line. So irrespective of the fact that this argument looked like an invalid argument at the first go, but this actually turned out to be a valid argument, which brings us to a very important critical thing. And let me tell you that. You can note it down if you want. A substitution instance of an invalid argument form can have a valid argument form, or you can have a substitution instance which can make an invalid argument valid. But there is absolutely no possible way in which you can make a valid argument from invalid retaining the structure. If you retain the structure of a valid argument, you put whatever values, the following structure, the following argument form, or the following argument which you will develop will always be a valid argument. However, in case of an invalid argument, what happens is that there can be some substitution instances. In some way you can put the values which can make that argument valid. Now this is a very interesting thing in logic, and that also brings a lot of questions in our mind, and please retain those questions in your mind, because the more you will keep the questions in your mind, the more you will work out with it, you will understand the nature, the structure of actually the logical world. So but we will be clarifying those things at a later stage. But right now, for the time being, you should understand that this was the argument which was given to us, and it was looking exactly like an invalid argument. But irrespective of the fact that it was looking like an invalid argument, it became, or it is actually, a valid argument. However, and this is an exercise for you, you take any valid argument. Right now you do not have many examples, you only know about modus tollens and modus ponens, but later on we will have more examples of valid arguments, and we will be solving them also using the natural deduction method. So at that point of time, you will have a lot of arguments, and you can try to put values in a way that can make the premises true and the conclusion false, but sadly this will not happen, or this will not result in. One thing more which I will like to tell you about it, that in valid arguments, like suppose right now you know about these kind of arguments, we will be using truth tables for a lot of decision procedures. But just to give you an idea that if there is a valid argument, what happens is, like if you have a valid argument, so suppose there is a valid argument and there is an invalid argument. Okay, so suppose there is a valid argument like P implies Q, P therefore Q, and here P implies, so there is an invalid argument, P implies Q, Q therefore P. So we know these two arguments. This one is a valid argument, this one is an invalid argument. Now the interesting thing is that suppose this is a valid argument, and we add some more premises. Okay, so like suppose an argument was given to us and we added more premises here, and we can do the same here as well. Suppose, now what will happen if we add some more premises here to this valid argument, and we add some more premises? I am not talking about what will be the premise, whether it is going to be R, whether it is going to be S, whether it is going to be P wedge Q, whatever. And right now talking in very generic terms. So whatever we have added here and whatever we have added here, irrespective of that, even if you add any number of premises to a valid argument, its validity will be retained. It will never change. The validity or a valid argument, irrespective of how many premises you have added, it will never change its validity. It will stay valid only. However, with very interesting, very important, or very suitable substitutions or premises, you can make an invalid argument valid as well. Fine. Now this is a very interesting result, and allow me, till the time we reach this position when we will be solving questions with rules of inference and all, you will find that we can prove it very easily, that how this is happening. But again, it should remain, or it should be in the back of your mind, that what is validity? Validity is such a strong concept that even if you add any kind of premise, false premise, true premise, related premise, unrelated premise, whatever. You can never change its nature. It will stay valid. However, in case of an invalid argument, with suitable substitutions, with suitable additions, you can change its nature and you can turn an invalid argument into a valid argument. So this is another interesting result which you should remember or which you should keep in mind for better grasping of the subject. Thank you.